it's a great day and a lot of nice weather. So thank you very much, Elvira, for joining this webinar. I'm sure it will be extremely useful for our participants. Just to introduce to our participants, we got introduced to Dr. Elvira, I think about more than 2 years now. And it was quite interesting for me to know that somebody has done PhD in compressed air system. I never thought that anyone would be doing such a narrow domain of discipline. So I would request Elvira to share her background as well as interest and how she got interested in compressed air and then further going into a PhD in compressed air.
Yes, thank you so much, Dr. Arshad. Hello, everyone. I'm very happy to participate in this webinar and talk about compressed air. So this is my main topic of expertise. You know, when people ask me how you got to make a PhD in compressed air, it was actually more on pneumatic side, on the fluid power. So I started my studies in the fluid power, in hydraulics and compressed air, and then continued further with my PhD then in Germany. So I did my studies in Russia, and then I did my PhD in Germany. And I'm very surprised because compressed air is used everywhere, but it's not studied. It's studied, but not, I think it's not enough, because 20% of the energy consumption of the overall industrial sector, it is a compressed air. And I think we need really invest more in the research there. Of course, there are companies, compressor suppliers, pneumatic component suppliers that do research there and development. But I think there is a huge potential. And this is why I really keen on the spreading the knowledge of this. And when you see in our field so compressed air is the big field, right? So I focus more on the downstream optimization. So this is basically everything that goes after the compressor. I look at the usage of compressed air at the component side, at the machine side, at the tools. And of course, this is the main usage that we need first to start optimizing. And when I go to some conference on fluid power, we're usually a minority, 3 or 4%, maximum 5% people that have presentation on pneumatics or compressed air. So, but I was always fascinated by physics, thermodynamics, because there is a lot of thermodynamical calculations there. And after finishing my study in fluid power, I decided that I want to go more in details than in pneumatics, because it's really interesting.
Thank you. Thank you. So it means that people doing their studies in mechanical engineering, mechatronics, and maybe in electrical engineering can follow this particular domain. How big is the opportunity as far as if anybody is doing specialization in this domain? So what is the kind of opportunity, what you will advise to the young generation?
So I know, at least in Europe, my background is that I studied in Germany, but I studied in Russia, but then I did my PhD in Germany, and in I worked in France, and now I live in Italy. So I more or less know the society of the fluid power. And if you want to go deeper into the compressed air and pneumatics, there are usually fluid power departments in various countries, or like with the various universities. So you're right, it's usually mechanical engineers, so or mechatronic engineers, and then there are specific departments that focus on hydraulics and pneumatics. But of course, there are also specific departments that focus on the compressors. And this is, I also think this link is a little bit missing now in the academia and in general industrial field. We have a usage of compressed air, and then we have a generation. And somehow they are not linked also on some standardization levels, or they're not linked on the research level, even me, I studied and I researched everything that starts after the compressor. So now I'm especially happy to be here because we have this really nice conversation with about with the rust car compressors, that you are interested in the optimization of the demand side, and this is very important. So for the students that would like to are interested in this topic, I think should just go and see what the universities can offer. Some courses, lectures. First, start listen to this, and then see if you like it to go further. But I can assure you there is a lot of interesting things on physics and thermodynamics that, if you like it, this is the topic that we really need you there.
Thank you. In engineering, generally people say that the thing which you can't measure, you cannot control it. And as far as compressed air, you can't even see the compressed air. So how do you see that it impact the industry?
Well, of course, the things that you cannot measure, you can't control, but you also can calculate those things. So I'm always, as a person that comes from academia, I can tell you that you can calculate so many things before you start to measure and analyze it. But of course, I work with the industrial sector, and it directly impacts their energy bill. There is, of course, a problem that as an energy manager, you usually get the bill of the electricity, and it's not written that it's a compressed air. And some companies think compressed air is free, but it's not. But of course, when you go, and we have very good energy managers in general, people with whom I work, they do the breakdown of the cost, and then they just realize that compressor is actually it's a big part of my energy. Just for as an interesting fact, as I already told you, it actually consumes 20% in industrial sector, of overall industrial sector. And if we talk, for example, about the automation, about food and beverage, chemical industry, in food and beverage can be up to 40-50%. So, and this has a direct impact. And it's not only the compressed air cost, operational cost, it's also safety. So safety for the operators, it's also the noise. And when we enlarge this topic and we try to focus only, for example, on the energy optimization, energy reduction, we can see how we can impact other topics, by introducing simple safety measures, it will actually reduce the energy cost.
Thank you. Elvira, generally people who do PhD, they do thesis and then they come on teaching in some university and thesis is lying in the library. But you did very differently. You thought of converting your thesis into an opportunity and you built a company around it. Can you please share how did you get the idea that it will be useful for the industry, and then how you build the company around that?
Yes, thank you. This is a very good question, and I like to share this story, and I hope that I can maybe inspire some students also about this. First of all, I must say a big thanks to my supervisor in German university and in general to PhD system in Germany. I was really happy to do my PhD there because it's very practical. It's not a theoretical. For example, if you compare it to like Russian universities, it's more theoretical, and maybe this is why the reason why there are good mathematicians and theoretical and quantum physicists, and of course engineers. But in Germany, you do it in collaboration with an industrial sector always. So I applied for the scholarship. I won the scholarship, and I started my project with a company. With several companies there. So there was a company, for example, Festo, with whom we collaborated, some companies that use pneumatic systems, so that the woodworking machines, automation machines. And the idea of my project was to help the companies to create a tool, a method, to choose the most cost-efficient technology. So I had to compare pneumatic drives with electromechanics drives. So basically, I needed to show them what to concept the pneumatic or electromechanic scheme of the machine, and to see to reduce the operational cost of this machine. So energy and do various and let's say prepare a roadmap for this. And of course, during this, I learned a lot from my industrial partners, because when you study only thermodynamics and calculations, I had to develop these calculations, but you cannot apply to them. You, as a PhD student, usually feel frustrated. But I visited all this, thanks to these projects, again, thanks to my German professor, and in general, the system that they created, that it's very close, the research with the industrial sector, I could do it together with industry. And after I finished this, everyone was happy with this. We had a nice report with the described method there, and I wrote my thesis based on this. Of course, there are a lot of theoretical things, but then I applied it to 2 machines. So it was one, the wine filling machine. It was a very fun project also to optimize the machine, filling machine for wine. And another one was the automation machine. So we established the method for them with our industrial partners. After finishing this and having this nice report, a nice thesis out of this, I started my work in the industry. So I went to work to Emerson. Now it is Aventix. It's the company who produces the pneumatic components, so cylinders, valves, filters, so all these components that use compressed air that comes from the compressor. I realized that in the industry, in the real world, let's say, not in academia, things are different, and energy efficiency is not the focus. And you can understand it because as the engineer in industrial sector, for example, I had to design those systems, the specific systems. And you could imagine that it could be more or less the same idea, that you apply some methods and so on. But in the industry, you are constantly under the pressure. Time pressure, you don't have 2 years projects to think about it. You have 2 weeks to deliver to the client the system concept and proof of concept, test it even, or like 2 months, 3 months. You don't have time to use profound simulation tools for that. So you need to really, you have the competitors on the market that also are going to provide systems, and also they're also going to be good. So you want to make your machine better, faster, and less expensive. So you're always on the price. And of course, you have other tasks to do. Of course, I was upset that I cannot do the nice energy efficiency methods there, and I have to adjust to this. But I also could understand my colleagues, and I also could understand, I started to understand how the market works, how the industry works, and what is the reality, that we cannot always think about it. So, but then I still wanted to have this idea of the energy efficiency. I was thinking how to make this method that we developed easier for engineers. So engineers like me can just calculate very fast the energy consumption, can choose fast the components, can put the energy efficient, not think as an extra thing, but have it like as a natural process. And I decided to create, started from the small calculators and small trainings. So I decided to start my own consultancy to teach engineers to think about energy efficiency. And then I created the calculator, online calculator, to choose the components, to calculate those components. And then we created the program. Basically, it is now it is the big program where you can create the pneumatic circuit diagram that tells you the cost of energy, it tells you the optimizations, and basically it was a gradual thing. It's not that I had like idea that now I do this. No, it came from the available knowledge from the academia. And in academia, you know, it's a lot of know-how, a lot of knowledge. But when you look at the industry is a little bit behind, and then like they don't implement everything from there, but it's coming. But sometimes this bridge is missing there. So, and what I wanted to establish this bridge. I wanted to bring the know-how on the energy efficiency components and solutions that are available into the real world, and make it simple for engineers. So now we have the platform, the tool. Like, it's not simple in terms of the development, but it is the tool, simple in use for the engineers, where they have availability to calculate their system, choose their system, and also connect with the suppliers of efficient solutions and see what's going on the market. So this is basically was the way, the path that we went through.
Yeah, thank you very much. Actually, it makes the whole learning very, very useful. And in our part of the world, I think instead of just having a thesis done and then put it in the library, we need to look into the possibility that how can we closely work with the industry. So coming back to compressed air, whatsoever my little interaction with the industry have been, generally the director of the company or the CEO, they leave the compressed air system onto the maintenance or the on the technical team, and they neither want to go into the details of what is happening with the compressed air, nor they make any effort to understand it. So what do you think, how important it is for CEOs, CFOs, or senior management of the company to understand the compressed air?
Yes, I think for CEO, CFO, it's mostly really on the level of the not only energy, but compressed air also assures a lot of processes. So if you have any problem, and of course they leave it to operational manager, all the downtime of the machine that works on the compressed air, everything depends there. So operator is also under the big pressure. And here I think there are two things. First of all, it's the energy price, and second of all, is the functionality. So in my experience, I have actually more projects where people come with a problem. So the maintenance manager comes with the problem that he has the high pressure drop, for example, or machine doesn't run. And then when we analyze the system, we say, okay, now if you implement this and this and this, your machine will be running nicely, and it's going to be good. But also it's going to be some savings. And then he takes this message to the energy manager. And then when those two departments are working together, then it is already the synergy there. So we have higher potential to get a nice project, on the optimization side. And it is doesn't only consider for example, only leak detection, but like the full analysis of the machine. I want to share with you a short example now, just to show you. It's a very interesting project that we are still doing. It is in the steel manufacturer, and I think you can see my screen now, right?
Yeah, can you please make it full screen? Yeah. Okay.
Yes. So this is basically the steel manufacturer came with the problem of the high pressure drop. So surprisingly, his compressor was running on 8 bar, but the pressure drop was 4 bar, 4 bars. So it's 50% of this. So it was, of course, shocking to see. And this is basically the machine. It makes the metal sheet, and then they use the compressed air to clean it. So they have air knives, and then they use compressed air to clean it. The moment they start the machine, they have this pressure drop. And of course, this was the problem. It was not the question of efficiency. They came and they said, we need something. It was they also had the leak survey done, and the maintenance manager came to the CEO and said, look, we need to budget to study this problem. So the leak survey showed that it was only 10% of leaks, but there was still a huge pressure drop. What was the problem? The problem was in the design of the full line before the compressor. It was not the problem of air knife, not a problem of the compressor, not a problem of any component there. It was the problem of the full design, because when we, as I told you, the problem also that we are trying to solve is the link between the compressor supplier, distribution line supplier, and the application. The problem was that the all the tubing was not correctly sized. And you cannot see it. It's not obvious when you only the machine supplier, or only when you compressor supplier, or only when you component supplier, because you supply some component and you say, look, you need this and this condition, but then something changes. They change one component, another adjust another line that also consumes energy and forget to calculate it. And you cannot blame a maintenance manager for that, or energy manager, because it is actually a complex topic. You need to talk with professionals about it. And when we calculated it, so in our tool, so we just created the model of this. We calculated the required blowing force there. We created we could find the location of the pressure drops there. We calculated the tubes that they had to install after this, and then identified the pressure of the compressor. So after solving this problem, we actually saw that we proposed them two options for the optimizations. And it's not only save the problem of the pressure drop and the problem of the cleaning the process that is operational manager cares about the most. It also shows the energy manager that if he implements the first option, he can save 30%. And second option, then he can save 63%, also depending on the payback period. And this is what I wanted to show, that it's not always only about the energy or functionality. It's usually two departments that are working together and two departments that need to work together. So.
Okay. Thank you very much. So one of the things which I have seen in the industry, that people just see the compressed air as one of the utility, but there are ISO standards for food and pharma separately, and textile and other separately. So how do you comment that how important these standards are to consider for food, pharma, and textile, so that people can understand its impact?
Yes. So regarding the ISO standards, I think we need to separate two topics. For example, the standards for the pharma that we have regarding compressed air, it's always concerning the quality. So the quality, also for the textiles, I'm not very familiar with the textile standards, but for food and pharma, it's always the quality, the cleanness, how clean the compressed air is. So this is what is regarding the process. But when we, as you said, look at the compressed air as the utility and how we actually design systems, this is already, and how we audit systems, this is already another topic. So when we just take the compressed air, not regarding the process, but how we actually treat it. I mean, of course, there is this famous standard, if I don't mistake, 1105, the one that is on the general audit of the compressed air. So there are mainly guidelines. There are no calculations inside the standards, but it's very good for the start. It's good for the beginning. So it tells that reduce pressure as much as you can, size correctly your pipes, check your demand side. So those are recommendations for their energy auditor or compressed air auditor to start. So you just you have a very, in my opinion, so it's very good start. There are all the factors that you need to consider. But there are no detailed steps. So, for example, I don't want to criticize it. I'm just trying to tell that there is a need of another thing that that is now in the development. So, because this standard was developed by the association that includes the compressor suppliers, but they say like, okay, adjust your demand side. Like, be sure your demand side doesn't consume too much. So, but what are the detailed steps of this? This is already has to be considered on the usage level. And right now I'm I'm an expert in the International Standardization Organization Committee for Pneumatic Systems. So this is basically the everything that concerns the usage of compressed air. I also can just show you an idea what it is about. Just sorry, 1 second. Okay, so this is here. So as you know, we can optimize compressed air usage of compressed air on various levels. So this is also important to understand. So we have end users. So this is basically the company that food or farmer or textile company that has the machines that consume the compressed air. And of course, they are interested the most in the reduction. So then we have the machine supplier. They're interested usually less because they don't consume compressed air. So they just supply, so they wanted to make machines cheaper. And then we have component suppliers for those machines. And component suppliers usually have some energy efficient solutions there. And of course, they want to integrate it. So, and this is important to have those links, you know, that machine suppliers also reduce consumption of the air. And there are various levels. So it's not only the level of the plant where we see first the leak detection, then we see the pressure level, pressure drops, distribution line optimization. There are also level of the machine, of the certain machine, and there is also level of the single axis system. So it's, for example, have cylinder with some components, and it's also level of the actuators. So it is, there are various levels that we always need to consider. And the standards that we're working now, it is been developed together with the, sorry, it's here, together with the Germany, France, and Japan. And there are also countries like Italy that are experts there, experts from China, from the UK and the US. So, and the purpose of this standard is really to look on this side here when we design the machines, when we design, when we choose the components. So first of all, we need to identify main air consumers. So what are those consumers? It's usually actuators. Improve the distribution system, and then calculate the energy consumption, and then be actually able to give this information of the energy consumption to the compressor supplier, you know, so we not oversize the compressor and we not oversize the actuators there, because there is the potential of savings. I think I have here some interesting information here, interesting slide. So the potential of savings in general, if we look at them from the compressor distribution to application line, it's huge. So in some projects, we could save like 60, 70%. And when we take the 70% as the 100% and look of the components of those savings, in the application can be saved up to 50%. And this is why I always say, start first with the application. You know, it's like you have the house, you want to reduce energy consumption here. You don't go and start with installing the solar panel. You don't start with your generation of your electricity. You switch off the light. So, and this is my message. First, switch off the light, check your applications, reduce your machine consumption, check the distribution, because it's very often, it can be a mess because industry grows. Every year they just buy new machines and then just put a pipe, a tube there. So, and then adjust the distribution, and then you go and then you optimize the compressor room, because there's also huge potential from using the efficient compressors installing shutoff wells to the heat recovery systems. So it also has a very big potential there. So this is I think it's very important to see also again like the holistic picture. And this is what the ISO standards come into your question is. ISO standard is focusing, now it's focusing in general in the maintaining, on some tips and advices, where to start, how to approach each component of the system. And now what we're working on, and I hope it's gonna be published soon and it can be in usage, it's basically detailed calculation and steps on how to optimize the application and distribution.
Thank you very much. We have one question from the participants. May I share with the participant that anybody who want to have question can please raise your hand, and then we will take your question. So there is a question from Mr. Omar Iqbal. He says that if they have a demand of sudden pressure and consumption dips at the consumer end, so what factors one shall consider in compressor selection?
Sorry, could you please just repeat the question? It is in the chat, right?
Yeah, it's in the chat by Mr. Omar Iqbal, 324. He posted this question. It says selection of a machine is very important in applications where there are sudden pressure consumption dips at the consumer end.
Yes.
So what factors shall be considered in selection of the compressor?
Yeah, of course, first of all, it has to be considered first the demand profile. So as I said, I mostly focus on the demand optimization. So when you ask here about the sudden pressure consumption dips in the consumer end, so first of all, check it why it happens. So again, before choosing the compressor and going in the compressor, and I think we have here experts that can help with the compressor machine choice. We need to see why something happens on the demand side. So, and there is usually an explanation for that. So when there is a sudden drop, or there is like sudden peak of the consumption of the compressor, of course, the first thing you can do is to compensate this sudden demand by a smaller compressor. But if you want to go in the more detailed analysis, there is a reason in your demand side why it happens, and you can eliminate this peak. So you might have some leakage in the machine. It might be that the machines work in this sequence, for example, and then they come like in the sequence together, and maybe you can just put another sequence there, for example. Maybe there is a higher consumer there, and you can reduce the consumption of this, because 80% of actuators are usually oversized. So maybe there are some blow-in applications that are not working correctly. So I really recommend first to check why this peak happened, who causes this peak. And then if you cannot compensate it, if you cannot eliminate this peak, then you need to compensate it. But as I said, first demand, understand why, who is the reason why this peak has happened, and then check also your distribution line, because it also can be the, as I showed you, for example, in the previous example, the pressure drop, when it was like the 4-bar pressure drop when machine starts to work. So we need to have two diagrams check the diagram of the flow pressure, and then the diagram of the machine working, and then just see who starts to work at this
Thank you.
time.
Mr. Hamad Altaf want to comment. So Hamad Altaf, can you please comment whatever you want to say? Hamad Altaf. Asif, can you please open his mic?
Thank you very much, sir. I just want to add a comment. The issue which was identified in the question can be solved by adding a small storage tank near that place. Air storage tanks, as per the requirement, this will help to maintain the pressure of machine, and we will avoid such sudden dips. This is probably due to as she mentioned, this is actually due to the design fault of the compressed air system. So if the compressed air system is not designed properly, then we face such kind of dips. So in this case, one solution can be just adding a storage tank near that place or near that machine. This will help their problem. Other than the leakages, if you have seen all the problems and further these problems come, then you can just add a small storage tank. This will resolve your issue. Thank you.
Yes,
Thank
yeah,
you.
it's a good point, but it will not solve the energy consumption problem. So, but this is the thing. Like when you add something new, then you still have their energy consumption. So, but this is, of course, it is helps to solve the problem. But as I said, first of all, check what causes this. So, what is the who works there? What kind of machine work to solve them? If it's not possible, then the air tank or additional.
Thank you. So we have Dr. Talha Hamdani from Textile University, Faisalabad, just to share that we have established Center of Excellence in Compressed Air at Textile University. This is a state-of-the-art facility where a lot of trainings and certificate courses are being conducted on 7 different aspects of compressed air, starting from selection of a compressor, because it itself is a very specialized domain, then siting, planning, and designing of the compressed air system, then the downstream equipment planning, installation, and pressure management, and then is the preventive and post installation maintenance. So Dr. Talha Hamdani is providing a lot of support. So Dr. Talha, can we have your comments in this regard, please?
Yes, sure. Thank you very much, Dr. Arshad Ali, for giving me this opportunity to share what's happening in Center of Excellence. By far now, we have conducted a lot of trainings and we have supported our industry to upgrade their knowledge and bridging the gap within the compressed air system they have. And as you mentioned, that there is still a lot of issues being ignored, which can cause financial losses and energy losses in the industry. So with this aim that we will keep supporting the textile industries and other allied industries where the compressed air is being used, to aware them how important it is, and we are in a way to enhance its capacity to further equip the more technologies to facilitate the industry and the students. Hopefully, we will together move further to get our objectives.
Okay, thank you. We have a question from Mr. Danish Beg. He says, like motors have rating criteria, does pneumatic machine also have similar rating criteria regarding the efficiency of compressed air consumption? Elvira.
So sorry, I was muted. So a good question. No, it doesn't have, because there are no standards that allow to calculate efficiency of compressed air for pneumatic systems. So once again, I'm not talking here about the compressor. Of course, there are ratio for compressor machine, but if we talk about the demand side, about cylinders, actuators, or blow-in application pneumatic motors that use compressed air and not generated. So I just want to be clear that it's 2 different things, and we divide them. In terms of the consumer, no, there is no rating criteria. It is the only rating criteria. It is the consumption, how much the machine consumes of compressed air, and there is no an efficiency factor. I did my PhD, for example, exactly on the efficiency factor, calculating those kind of things. But for each components, it doesn't, right now doesn't exist. So the main criteria is how much the machine consumes. And yeah, you cannot say if it is consumes too much or too less unless you analyze what the machine has to do and if the components are chosen correctly. For example, if we take cylinder of the diameter 40 millimeter and cylinder of the diameter 50 millimeter, under the same pressure, they consume, the difference is 55%. So, but the question is like, do we choose, is it maybe enough for us to get the cylinder of 40 millimeter? And this is main criteria, how much it consumes and how much we can save.
Yeah. There are many questions in the chat window, but since we have short of time, I will request Asif to please, we have a hand raised from Mr. Nasir. So this will be the last question. Nasir, can you please have your question? Asif, can you please open the mic?
Yes, sir.
Nasir, sir.
Can we calculate? Hello, did you
Yes,
hear me?
please. Yes.
Yeah, I have question, sir. How can we calculate the line sizes according to the machine distance and machine consumptions?
Yeah, good question. So there is a nice calculation based on the pressure drop calculation. I even have a YouTube video about this, so maybe I can send the link. You can find it. Just start my YouTube channel. So be careful. Don't use the hydraulic calculation because you need to use the always remember the compressible fluid. So how it works? There are general calculations for the diameter of pipe. Then we need to see the pressure drop. So we need to calculate the pressure drop. It's a long equation, and then we need to see the pressure drop can be, for example, 0.7 bar. So if it is too much for you, and I can tell you that yes, it is too much for you, then we need to check the pipe and go to the next next diameter. What I can recommend you that I have some information about this, so you can ask me a question. I can send some information about this. I don't know, maybe in the chat or somewhere else. And we have a software, the simple software where you can calculate it. So where you could put the required cubic meters per hour and then see the length of the pipe and diameter of the pipe. So, and then this is based on the pressure drop calculation because it is an iterative process. You cannot just make an Excel table and calculate on this because there is no like unique equation where its diameter is equal this. So this is this is very important. But I have the what I wanted to say. I see that there are many questions and they are very interesting. So I would love actually to answer them. I have the small community chat of directing of my company. And if you don't mind, I just put here the link to the group. And then there you can just log into this group and then ask the questions. And then I'll try to answer all the questions. So we can, if you have any other, let's say it's here. So this is basically if you go on the directing, sorry, just need to everyone in the meeting. If you go in this, exactly. So if you go in this group, so because we're also trying to support the engineers and people that are interested in this, there are some educative material. So you can see also some demand side optimization, and you can ask there the question. And we have also, so would be really happy also to see some compressor experts there because sometimes I get questions about compressors specifically, and I'm like, no, I can optimize with the machine and calculate the distribution line, but compressor experts have their own niche. So please go there and just ask your questions there. So maybe we can.
Thank you, Elvira. Before closing, we will have remarks from Mr. Imtiaz Rasgar. But before that, I would like to thank you very much. And just to share with the participants, Elvira will be visiting Pakistan we are planning to have her visit to some of the universities and some of the industry. And she had been kind enough to also co-supervisor some MS and PhD thesis. So we will be discussing about that. Dr. Tala Amdani, you have raised hand. Please, I will have your comment first, and then I will request Imtiaz Sahab to share his comments. Tala.
Sorry. So it was a thumbs up for appreciating her visit in Pakistan. It was not regarding a
Okay.
question. Yeah.
Okay, thank you very much. So, Imtiaz Sahab, can we have your comments? You have spent your life with the compressed air, and we also learned quite a lot, and Elvira also found it very interesting. So please share your comments.
Thank you very much, Dr. Ashwin. And also, Elvira, thank you very much for taking this time. And I think our viewers have been very interested in a lot of things. And for a detailed discussion, this was a rather short webinar. But I hope that once you are here in Pakistan, we can have some longer discussions with the people from our industry and from the academia. And people who are friends who are listening to us, they can share their interest if they are from industry, what kind of help they would require as concerned their air compressor system. So we can prepare Dr. Elvira to come and deliver some lectures here and also interact with industry. And maybe we can, with her help, we can solve some real problems in the industry. So Dr. Arshad, thank you very much for being with us today. And Elvira, thank you very much. And everybody on in the webinar now, also thank you very much being with us. Thank you.
Thank you, Ji. We wish good luck to Elvira and all the participants, and we will meet again very soon in order to benefit the society at large. Thank you.
Thanks a lot. Thanks a lot for having me today. And I really appreciate the connection of the demand side and compressor suppliers, so in the academia. Thank you.
Thank you. Bye.
Thank you.